Hello there and welcome to this talk, which is an introduction to studying earth sciences at Clare College. Now, whilst we have the coronavirus epidemic, of course we can't get out and come visit you in schools to talk about the different subjects that you could potentially study at Clare and talk about why Clare is such a great place to be. So what we're going to do is try and do this in a virtual way through the Clare Schools programme, and this video is hopefully going to provide you with some information about what is earth sciences, what does it include, what could you potentially do as part of this subject, and why is Clare a great place to be to study earth sciences in the first place. So my name's Sam Wimpenny and I'm an earth scientist at Clare. I'm a geologist. I'm interested in studying earthquakes, but for about the next 10-15 minutes I'm going to hopefully try and encourage you and show you that it's a great subject to be part of, and I'm sure that if you're interested in studying natural sciences, this broad range of different subjects, maths, chemistry, physics, biology, then I'm pretty sure that earth sciences would also be a subject that you'd be really interested in. Okay, so what is earth sciences firstly? So it's really a combination of different things. It's a mixture of geology, so geophysics, geochemistry and geobiology, and these are probably lots of words that you may not have come across before because it's often not taught at A-level or GCSE. But all of these things and all of the skills that you've developed as part of studying science at A-level really are very applicable to these subjects. So geology is really the study of rocks and the study of the materials that make up the earth. And it can involve mapping out those rocks, and it can involve studying their compositions, what they're made of, and the minerals that form them, all the way to studying the fossils that are within them. Geophysics is more about studying the physical properties of the earth. So that could be using seismic waves, for example, those generated by earthquakes and the shaking that you feel in earthquakes, to try and map out the structure of the earth's interior, work out things about, say, the materials that form the core of the earth and what's in the earth's mantle. It's deep, deep down into the earth's interior. Geochemistry is more interested in obviously the chemistry of the earth and the materials that make up the rocks. So that might, but it can also include things like what makes up the oceans and what makes up the atmosphere. So lots of geochemists right now are very interested in the interactions between the solid earth, that's the rocks that make up the earth and its mantle and its core interior, and the atmosphere itself. Geobiology is obviously, again, something that kind of does what it says on the tin. People who are geobiologists typically interested in how has life on Earth developed and how has that affected the processes that happen on the Earth, and also potentially on other planets like exoplanets. So all these different strings of earth sciences are all different topics that you would touch on as part of the Earth Sciences programme at Cambridge. And between all these different subjects you have interdisciplinary fields that really are the kind of core of earth sciences. So it's a very diverse subject, and you really need to know lots of different bits and bobs about these different subjects to try and answer some of the interesting questions. So for example, if you're interested in oceanography, if you're interested in studying the oceans and how the oceans are affecting climate change, for example, you might be interested, or you might need skills from geobiology, so you could understand how the biological systems within the ocean modulate, say, gases and gas transfer between the ocean and the atmosphere. But you might also need to know some geochemistry. You might need to know about the chemistry of those processes and how these different materials are, say, sequestered in different rocks, for example, over geological time. My personal interest is geophysics. I'm interested in earthquakes, but I'm also interested in going out and mapping where faults are, looking at faults exposed in different parts of the world, and looking at how we can use ancient faults as analogues for modern ones too. So earth sciences, I think, is relatively unique in that it's very, very interdisciplinary in this way, and knowing lots of different bits and bobs from these different subjects really helps you address kind of modern research questions. And natural sciences at Cambridge really does set you up very well for becoming a great earth scientist. So I'm sure there's going to be other videos that explain what natural science is in general, but just to give you a brief overview, it's essentially quite unique to Cambridge. There's only a few other universities that offer a natural sciences course. But essentially, instead of studying one major subject, like going to university to study chemistry, for example, what you would do is you'd come and you'd take a suite of different subjects, normally 4 in your first year, and that could be anything from maths, physics, biology, chemistry, material science, or earth science. And then in later years you would slowly narrow down, and you would choose one or two that you're particularly interested in, and specialise until you do, say, a dissertation, which is a final project that contributes, that's a bit like coursework that contributes towards your final degree grade. So, you know, earth sciences is really fits into that very nicely, because it stays very broad and stays very general in terms of the kind of material that you'd be learning and potentially doing research into. So I thought it'd be worthwhile saying something about what's really unique about earth sciences, and why you should maybe consider taking earth sciences as an option if you were to come study natural sciences at Cambridge. And really the first thing that I could think about is this interdisciplinarity, and that if you are that kind of person who's interested in lots of different things, earth sciences is a great fit for that. You get to do all sorts. One minute you could be using computers to build computer models of different processes. The next minute you could be out in the field, sat in a peat bog somewhere, drilling cores somewhere in the middle of Norfolk. The second thing obviously follows on from that is fieldwork. Fieldwork's great. It gets you out to different places, you can travel around the world, you can even just travel in the UK, but it's a great way to get to know your colleagues, get to know your peers on your course, and it's also great to see these different places. And often fieldwork takes you to places that you'd simply just never visit otherwise. So the third thing I could think about is really what I've called the research timeline, and this means how quickly you go from being in university, starting your degree and learning about the subject, to being able to do research that's at kind of the front end of what we're able to do. And in a lot of subjects, the things that you start learning when you turn up to university are often equations that people wrote down 400 years ago, for example. Whilst in earth sciences, it's a very young subject, so a lot of what you learn in general is really very recent. Plate tectonics, for example, was only really formalised 50 years ago, so it's in the lifetime of most people's grandparents. And therefore, a lot of the material that you learn in the course is very recent, very new. You learn about lots of new technologies, like radar satellites, for example. And you will be really, at the end of your degree course, trained enough that you could undertake research that would be essentially publishable. You're right at the forefront of what's going on. So I think that's quite unique about earth sciences, in that because it's such a young field, you can very quickly get up to speed with where the subject's at. The other thing I think is really important to stress is the fact that the earth science community is a very friendly and supportive one. Everybody is all working towards a common goal. There are very few egos involved in the subject, and it's all really driven, I think, partly by fieldwork. If you have to get on with people, you have to get on with people on fieldwork. So everyone is generally very nice. It's a very friendly department, and it's very supportive. I think another thing that's quite unique about earth sciences is that there are these quite close ties between the academic research that we do and some vocational and industry applications of the science that we produce. So that's more than just the standard oil and gas and mining that's really starting to reduce now, I think, in terms of the number of people who go on to do that. More people are going on to do things like modelling hazard. Lots of people interested in natural hazards go and work for companies that are interested in trying to work out best practices for informing governments about how to build cities. People interested in volcanoes going to study how gases are partitioned in the atmosphere and how ash disperses after volcanic eruptions, and they can use that to inform, say, the aviation industry. So there's a lot of very close ties between academia and vocational aspects, and those vocational aspects are often either climate related, health related, or they can be resource related too. And the final thing I was just going to re-stress is that fieldwork is just an incredible part of what you'll do. Some of the opportunities in the Cambridge course include going to Greece to study active faults and active tectonics. These are things that generate earthquakes. Then you go to Spain to look at some incredible sediments and also exhumed ancient faults there. You go to Arran in Scotland and Skye and look at some ancient interiors of volcanoes and magma underground. And you also go to Cornwall and look at the exhumed interiors of old mountain belts. So it's really a very diverse subject, and also gets you to travel a lot, and I think that's an extremely exciting part of earth sciences that is really very, very unique to the subject. So hopefully I've convinced you that earth sciences is at least an interesting thing to do, and that it might be something you'd be interested in doing at Clare. So the other thing to really convince you of is why think about applying to Clare in the first place. What's unique about Clare, and why does applying to a particular college for a subject potentially affect your experience whilst you're there? So there are other videos on the Clare Schools website that tell you about the supervision systems. This is something that's very unique to Cambridge and Oxford, about where the teaching, although you do have lectures in big lecture halls, you also have small scale teaching where you one-on-one or one-on-two or three, you and normally either a member of faculty or a PhD student or a postdoc in the department. And these are the people who will be really keeping up with you, teaching you, marking some of your essays. And for the science subjects, often these supervisions are done by your Director of Studies in college. And our Director of Studies is Ollie Shortall, and he's a geologist but also works in astrophysics, and he's interested in all sorts of things. Principally he's interested in this geochemistry, geophysics, geology side of things. He's also interested in some fascinating things about exoplanets and how we can use observations from exoplanets, particularly about the chemistry of their atmospheres, to infer things about what's going on in their interiors. So really, really interesting subject, and he covers a kind of left-hand side of this diagram, this geology, geophysics, geochemistry section. One of the other people we have is Dave Hiddell, and he is essentially interested in climate and how climate change has happened over a period that we call the Quaternary, so the last few million years, and how we can use observations of climate records from rocks, from ice cores, to try and reconstruct past climate history. What would that tell us about what's going to happen in the future? So he's kind of interested in this geochemistry, geobiology, geology side of things. And Ollie and Dave are the two people in Clare who will principally be doing the teaching for maybe people in first year, second year, and third year. Normally when you get into the later years, the teaching moves from, the supervisions at least, move from within the college to within the faculty itself, so you'd be taught by lecturers from all sorts of different colleges. The final person who's at Clare is Nigel Woodcock. Nigel's retired now, but he's still around, and he is a brilliant resource because he literally wrote the book about the geology of the United Kingdom. So people doing mapping projects in the UK, which is something that I'm just going to talk about in a minute, he's a great resource for us to have around. I'm also at Clare, but I'm only going to be here for a few years, but I cover this geophysics/geology connection with some of the teaching that I do. The other thing that's probably worth mentioning is the mapping project, the geological mapping project, which I think is something that really sets earth sciences aside from all the other subjects. So after you finish your second year at Cambridge, and if you choose that earth sciences is the thing for you, you like it, you enjoy it, you think you're good at it, then what you would do is you would organise your own projects, you and normally a partner, to go to somewhere in the world and map a section of rocks. And this is normally, a few kilometres square, and it could be anywhere from Newfoundland to the Canadian Arctic to South Africa to, in your backyard somewhere in the UK. But really this is a really unique opportunity because you plan the projects, you undertake it all, you write it all up, and this contributes a significant fraction of your final grade. But I think it really stands out because it's such a self-driven project. And we've had lots and lots of fantastic projects that have produced work that's good enough to be published and has led to some really, really interesting science. So I think geology from that perspective and doing earth sciences, taking earth sciences is really a kind of exciting thing that people should be considering. So here's just a slide of the summary of what I've said. So, earth sciences is part of this Natural Sciences Tripos, and when you're applying, you don't have to decide that you want to be an earth scientist. You can decide that when you're here and when you're going through the process and when you've been to some lectures and realise what it's all about. But I'm just giving you this information now so that you know what's out there. Second thing is that it just includes a huge broad range of subjects, all the way from people studying climate change, little bugs, paleontology, all the way up to studying exoplanets, the formation and structure of the universe and the solar system, you know. It really has this huge scope to it. So you never really feel like you're being narrowed down and studying one very small and particular thing. I'd say Clare is a great place to do this. It's got a great community of earth scientists, great community of people, students and staff teaching there. So you've always got this great outlet if you were to come to Clare. It's really friendly and inclusive subjects. Lots of fun things go on. We've got a great undergraduate geological society, the Cedric Club, who organise lots of events, lots of trips and getaways, and also lots of talks and lectures. And you can really, really quickly reach the forefront of the research field in this subject just because it's so young. And finally, just to reiterate, the chances for travel are pretty incredible. It's going to some awesome places on field work. So hopefully that's given you a good idea of what it would be like to study earth sciences, what it is, why Clare's a great place to be and do it. So this will be the end of this video, but I'm also going to try and upload one that's a sort of taster lecture to show you some of the kind of material that you might learn as an earth scientist. So thanks for listening.